Hello grade 8s, this is unit 3 where we are going to learn how to multiply and divide fractions. This is lesson 3.1. It's titled Using Models to Multiply Fractions and Whole Numbers. For example, what's 1/5 times 4? There's a few methods we could use, but let's use a model first. Let's draw out some fractions. Here's the first one, the chocolate bar method, right? We got some chocolate bars and they're broken up into 5 pieces, that's why it's fifths, and there's 1/5. But we didn't just draw it once, we draw it how many times? Times 4. We wrote it 4 times. So, how much of the chocolate bar, how many chocolate bars would these pieces that I'm talking about, these fifths of pieces, make it up to? Well, we could, in our heads, kind of imagine these pieces moving in here. So this moves up there, and this one could move into the next spot that's open. This one could move here and fill those spots in. And how many fifths of this chocolate bar would be left? There'd be 1, 2, 3, 4. So this equals 4 fifths. So that's using the pictures or chocolate bar method to try to explain this. But there's some other ways we can do it. Another way. So this was the picture way. The next way could be repeated addition. So I'm going to do the exact same example. So we've got 1/5 times 4. And if we remember, multiplication is just the same thing as repeated addition. We're going to add this thing here 4 times. 1/5 plus 1/5 plus 1/5 plus 1/5, 1, 2, 3, 4 times. And if you remember, if you have a common denominator, if you have the same bottom, the same denominator, you can just add what's on top. This becomes 1 plus 1 plus 1 plus 1 all over 5. And if we add that up, it is 1, 2, 3, 4 over 5. And we get to that same answer, 4 fifths. I'm going to use a little more complicated fraction for this next one, the next method. I call it the number line method. So what about this question, 4 times 3/4? So we drew a number line, and we're going to label it 0, 1, 2, 3, 4. And I have drawn these increments based on this number down here. So whatever this number is down here, that's how many boxes are going to be from each of your whole numbers. This determines the number of number of boxes you put between your whole numbers. Okay, so because that's a 4, I left 4 boxes between 0 and 1, 4 boxes between 1 and 2, because then each box becomes 1/4, right? Because this is a half, this is a quarter right here. Okay, and all we need to do now is jump up from 0 by 3/4. We're going to jump up by 3/4, which would be 3/4, and that was 1 time. We're going to move up 3/4 again, that's 2 times. We're going up 3/4 again, that's 3 times. We're going up 3/4 again, and that's 4 times. So right there, we found out that 4 times 3/4, it equals, what did we end up at? 3. That's where we ended here. 4 times, we jumped 3/4, and we ended up at 3. If you have a really large number as your denominator, sometimes you could maybe say that that's every half box is one of these. So you could have done it that way. But that's only when you have really large denominators. Another method is called the counters method. So what if we do this one? Let's go with this question, 21 times 2/3. Well, what you can do is take 21 and put it into 3 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, oops, I skipped one, 19, 20, 21. So we've got three groups right here. So we know that 21 times 1/3 would be one of those groups, which is 7. But this was talking about two groups. And what do two groups have? 7 and 7, which is 14. So this equals 14. We could also do the pies way, where you have some pies. I'm going to draw some out. Imagine I'm better at drawing than this, and I draw them into an equal sizes. Pretend those are all the same size. I know I'm not the best drawer. And let's say our question we're trying to answer is 5 times 3/4. So let's draw this out. There's 1/4, 2/4, 3/4. Okay. And what you can do is take the one on the right, and we're going to take these pieces, and we're going to fill in these other ones. So this piece right here, we're going to move over here and fill in that spot. This piece down here, right, we're going to take it and fill in this empty spot. This piece over here, we're going to take it, fill in this empty spot. And once we're left with only one pie left that has some spots, we can count these up. We have 1 full pie, we have 2 full pies, we have 3 full pies, and then we have 3/4 of a pie. So what is our answer here? It would be 3 and 3/4. Because we have 3 pies and 3/4 left over. Sometimes you have to take them from more than that. But that's another model. And finally, the last one is what I call the multiply trick. So let's take any example here. Let's do 7 times 7/9. With this one, all you have to do is multiply this number times the top. So first, multiply whole number by numerator. That's the first thing. The second thing is what we'll do next. So if we do that, 7 times 7 is 49. And then we just put it over our denominator from that first fraction. So that 9 goes down there. Let me use some color to show it. Okay, and the second one is use the denominator from the fraction. Okay. And if that's what you're allowed to leave it with, if it says improper fraction, you can leave it that way. Or sometimes it's good to pull out whole numbers and do that. So think, what number can you count up, multiples of 9, that is still below 49? So count them up. 9, 18, 27, 36, 45, and then 54 is too high. How many times did I count? 5 times. I counted up 5 times, and I got to what? 5 times 9 was 45. How many more do I count to get to 49? There'd be 46, 47, 48, 49. 4 more times, so that's 4/9 still left. So this is equal to 5 4/9. So today's assignment will get you to try these different methods, whether it's the picture methods where you use bars, or maybe the pies that we did later, or if you switch it up and do repeated addition, or if you use a number line, or you use counters, or you use pies, or maybe you just do it this way if this way is easier for you. But do the way that it says in the book to do. And after this assignment, maybe a couple more, you'll probably know which way that works best for you, and you'll be able to use that on the exams. There's another type of question that you will see, though, in your assignment, and it's an important thing to be able to know. This is when you're trying to figure out what a fraction of a whole number. So I'll write some example here. So here's the question. It says 9/11ths of the school's 121 students are away sick today. Okay, that's pretty severe sickness for that many kids to be away. I've never seen that, but it is possible. And it says how many are at school. So how many students are at school, and how many, I meant to say, are at home. How many are at home and how many are at school? So what it's asking is, what is 9/11ths of 121? 9/11ths of 121. When you see this word of, it means multiply. So what we're going to do here is we're going to take 9/11ths, we're going to multiply it by 121. Now you could do this a few ways. You could take 121 and put it into 11 groups and then count up or add up how many are in each of those, which in essence is you would be dividing, right? You'd be taking that 121 and dividing it into 11 groups and then multiplying it by 9. So think about it this way. This would be the same thing as 121 divided by 11 times 9. It's actually true that this is equal if you just flip those. So 121 divided by 11 is 11. And we still have our times 9. What's 11 times 9? It's 99. So how many students are 9/11ths of the school students, the 121, were away sick. So how many are at home, assuming they're home if they're sick? That would be 99. So there are 99 students home. At home. But it also asked, so always these word problems, make sure you've answered everything. It also asked how many are at school. And I like to use this to say therefore, that's what those 3 dots are. Well, if there's 121 students and 99 are away, that would mean that there's 22 students at school. There are 22 students at school. So this is another way that you can do it. If you have a question where you have a fraction times this, you can actually do the division first and then multiply by the numerator of the fraction, like this. Just for sake of it, I'm going to write it out with the counters. So I just went along and I went 1 dot in each of these groups and counted up until I got to 121. And look how many are in each of these groups. There's 11 in each of these groups. And if I circle 9 of the groups with blue and counted up all the dots in there, you'd be left with 99, which is how many are at home. And then if you counted up these ones here, this would be the 22 that are at school that day. Let's pray that never happens.